Hello, this is Jeremy Miners of Agram LLC, and today I wanted to talk to you about the innovative water management systems being employed at the Huronview Farm just south of Clinton, Ontario. Now, before getting into some of these different methods, I wanted to give you just a brief explanation of what this farm is about and how it is being managed and how it came to the point of developing some of the most innovative water management systems to be tested in Ontario. For decades, the County of Huron has rented this 47-acre field to local farmers for 3-year terms. In 2015, the County Council rented it to the Huron Soil and Crop Improvement Association to use as a demonstration farm to improve soil health and water quality. Volunteers from the Huron Soil and Crop Improvement Association farm it with reduced tillage and increased cover crops, which improves soil organic matter and reduces erosion. While organic matter improves infiltration rates and water holding capacity, systematic drainage was still needed. It was at that point in 2018 that the Huron Soil and Crop Improvement Association contacted Agram LLC to come and speak with them about the different potential water management systems that could be used to remedy their soil moisture issues. Agram LLC specializes in advanced water management systems and designs everything from surface drainage to sub-irrigation systems, even on rolling topography like is found at the Huronview Farm. In this particular situation, we weren't only just interested in increasing yields, but also being able to save soil and reduce nitrate runoff. Before long, not only was Agram working with the Huron Soil and Crop Improvement Association, but also with the Ausable Bayfield Conservation Authority, the Land Improvement Contractors of Ontario, and other partners in order to develop a water management system that could be an example throughout Ontario on different methods that could be used. The development of the water management designs at the Huronview Farm was truly a collaborative effort. Beginning with topographical data taken from RTK surveys, soil information from OMAFRA, and also precipitation data from the local community, original plans were developed by Agram. These were then brought to the Huron Soil and Crop Improvement Association, the Ausable Bayfield Conservation Authority, the Land Improvement Contractors of Ontario, and revisions were made, many revisions, until a plan was developed that would not only be able to have the best results in terms of yield, soil loss, and water quality, but also be able to be monitored so that the advantages of these different systems could be analyzed. After this iteration process, which is used by Agram for developing nearly all of their water management plans, a final design was created and agreed upon by all the parties involved. This final design then was transferred into an electronic file so that the contractors from the Land Improvement Contractors of Ontario would be able to install the system according to the design agreed upon. The final design began installation then on June 5th, 2019. This was done as a field day in which folks from the community and across Ontario were able to come and see the installation of these innovative water management systems. Now, there are several different types of water management systems being tested at the Huronview site, including a control so that the variations in yield can be monitored, and also areas for expansion. We are just going to focus on 3 of the different tests in this video. The first is that of tile layout and tile spacing. There are multiple different layouts on the field, including contoured and pattern systems. These are done at different spacings as well, as that is a common question nowadays on how close should our tiles be spaced. The next method of study is that of controlled drainage. Now, controlled drainage is the ability to more or less turn on or off your tile drainage system. And in this case, there is a site on a contoured system that is being monitored for water quality as well as yields and water flow. Now, the last, which is new to Ontario, is the use of what's called a broad-based terrace. This type of water management innovation is able to slow down water movement on the surface and thus be able to save soil. Now, let's get started with talking first about the subsurface tile systems. The advantages of tile drainage are well known. They reduce soil moisture levels, allow for earlier planting and harvest, and, most important of all, increase yields. It is through the developments over the years, particularly those of the land improvement contractors of Ontario, that have allowed for systematic tile to be installed accurately and with high quality. And the standards from Ontario have been applied throughout the tiling industry, including in the United States. Now, that said, there are still a few questions in terms of what is the best method for tile drainage, particularly on fields with high slope like the Huronview farm, which has slopes of upwards of 8% in some locations. Should the tile laterals be placed in such a manner that they go uphill? Should they be placed across the hillside? Or should they be placed on the contour? And with this, Huronview is an example of all of these different methods, and then with the monitoring that is going to occur, be able to determine what might be the best for these types of farms. Now, before getting into the different systems on the Huronview farm, I'm going to give you a quick basic summary of what pattern tile is. On the following schematic, you can see that there is a main, which is a larger pipe, and then there are laterals that are placed into the larger pipe. The main provides the main avenue for water to be removed from the field, while the laterals provide smaller tile that cover the entire field. It's almost like if you think of a highway system with country roads. The main route, the main, is where most people will eventually end up as they try to travel, while the country roads are the smaller ones that allow people to get to the main. This then applies with water in the field. Now, systematic tile is the placement of the main and laterals so that there is entire coverage of the field. That way, the field drains more uniformly. Pattern tile is a well-known investment, and current methods have typically focused on trying to provide that coverage using straight lines. On the Huronview site, this more conventional method is being applied and being viewed in terms of different types of spacing, which is a good question. With larger rain events, having closer spacing would potentially allow for more rapid drainage. The cost of that is more tile, of course. Now, on the plot, there are several sections where there is variation in spacing. In terms of pattern tile, here is an image of one where there is a 15-foot space system versus a 30-foot space system, and it is going to be monitored in terms of water flow. Contour drainage tile is a bit different layout of pattern tile. Instead of having straight lines, the laterals match the topography of the field while maintaining slope. This does increase the amount of time it does for installation, but the advantage is that you're able to keep a more consistent depth for each tile lateral, and each tile lateral, particularly on sloping ground like the Huronview farm, is able to better intercept the water as it moves downhill in the subsurface. Similarly to the pattern system, there are sections of the farm that are testing whether or not closer spacing of the contoured system versus wider spacing is advantageous. On this particular section, the lower ground, which tends to be wetter, has the closer spacing. It also comes to question, does layout matter? Should systems that aren't going to be potentially taken to controlled drainage or sub-irrigation, should they be on a pattern system, which takes less in terms of design time and installation time, or is the contoured system going to be advantageous? On one section, on Bob Gibson's farm, there is a test where there is a portion of the field in systematic tile and a portion in contoured system. Contoured drainage systems also have the advantage of being used as controlled drainage systems on fields with high slope, like the Huronview farm. Typically, controlled drainage systems in the past have only been able to be applied on flat fields, those with less than 0.1% slope. For fields that have greater slope, and in the case of Huronview, high slope like 8 to 9%, these systems on the contour are able to benefit in the same fashion as those that are on pattern systems on the flatter fields. Now let's first talk though about what controlled drainage is. So controlled drainage is the installation of a control gate on a main. This control gate is able to raise the water table to a specified level so that it can restrict the water flow and thus be able to reduce nitrogen runoff and preserve water resources in the soil profile during the summer months, while when drainage is needed to have these gates open, allowing for a free flow. This schematic shows how it is actually placed on the mains. Note, this is the same schematic as before. Now, though, you have gates placed, which are placed based on elevation and also, in case of flatter fields, number of acres used. For a contoured system, it is necessary to be able to place these gates to develop new elevation zones, or almost like an underground levee system, where water is retained at each particular elevation zone by its own individual gates. This then allows for each gate to be able to better manage that water table between it and the next gate, and thus be able to maintain higher water tables when desired. For the Huronview site, a contoured controlled drainage system was installed in the northwest portion of the field, as shown on these maps. This system has the gates located on the outside of the field along the path. This did create a situation where some of the laterals were rather sharp turning, which in some cases can be a little bit much for the installation in order to make those corners. However, it is understood that when necessary, these corners can be made a little bit shorter and turned a little bit sooner so that it's more feasible for installation. It is definitely the case that Roth and William Drainage did an excellent job installing these contour lines. With these control gates placed on the outside perimeter, there is also monitoring systems that have been placed by the Ausable Bayfield Conservation Authority, and this monitoring is for water quality, water flow, and then coupled with the yield data that is going to be coming from harvest, be able to give a full range of advantages and disadvantages from this type of system on the contour. The last water management innovation that is going to be discussed in this video that is on the Huronview site is that of the broad-based farmable terrace. In the United States, the broad-based farmable terrace are used often and are usually applied on fields that have suffered from soil erosion and have high slopes, usually above 2%. The purpose of these terraces is to slow down water movement. When water is moving downhill over an extended period, it is able to build up velocity and volume, and with it take soil along its route and then deposit it at the outlet. The broad-based terrace is designed in order to slow down this water movement and thus be able to reduce the amount of soil erosion that is on the field. These terraces can be designed with subsurface drainage systems, as is the case here at Huronview. For these terraces, the first step is to consider what the topography is. The topography determines what the spacing and size of each of these terraces are. It is also a determinant in terms of whether or not a waterway is used as the outlet for the terrace, or perhaps even a tile riser. The next stage, of course, is to consider precipitation, which is always an important part of determining the size and type of surface drainage system you need. For this, 10-year rains or 30-year rains are then analyzed to determine the size and the amount of water that is required for each terrace to take. From that, then, the terrace design can be generated. For the terrace to be constructed, the first step, depending on your soil, of course, is to remove the topsoil. Doing so allows you then to be able to replace that terrace after it is being built out of the deeper, potentially more clay layers. When the terrace is constructed, it has what is known as a terrace top, a channel ditch which moves the water on the uphill side, and then the appropriate slopes. That way you're able to continue to maintain the farm over the particular terrace. A lot of times when we think of terraces, we think of very large terraces like you would see in Southeast Asia, where you have on rice fields these mountains that have flat areas rising up in another one. How could we possibly farm that? That is not the broad-based terrace. The broad-based terrace tends not to be very noticeable once constructed. And the purpose is to just slow down that water movement while allowing you to maintain your farming operation. Now, when a terrace is constructed, it then has its topsoil replaced, and over the years, it does have to be maintained, but doing so requires very little time as long as that channel ditch is able to continue to move water to where the post riser is or to the waterway. Thank you for joining us on this video about the advanced water management systems being tested and applied at the Huronview farms. And special thanks to the Huron Soil and Crop Improvement Association for their innovation and forward thinking in terms of trying to benefit not only this farm, but all farmers of Ontario. Also, to the Ausable Bayfield Conservation Authority for doing the monitoring of this water management system so that we can learn about how it affects our water quality and soil preservation. Also, for the land improvement contractors of Ontario, it is through your great work and high standards that these types of systems are feasible today. The whole world looks to the LICO in terms of what is the best practices and how tiles should be installed. Also, special thanks to Bob Gibson and Rick Kutstra for using their farms as well as the Huronview farms for testing purposes. Thank you so much. Now, before we go, I'll tell you a little bit more about Agrom. Agrom LLC specializes in water management design and consulting. In fact, that's all we do. Beginning back in 1993, Agrom developed one of the first softwares used for the design of pattern tile systems. This began right when RTK and GPS first came into the agricultural market. Since then, not only maintaining and developing the state-of-the-art software that is used for tile drainage design, we also focus on designing for drainage contractors and farmers directly. The types of systems that we design are from surface drainage to pattern drainage, all the way to more complicated controlled drainage and sub-irrigation on rolling topography. We work directly with the farmer and contractor, and we do not believe that there is a one fit to every field type of design. Our preferred method, just like we practice here at Huronview, is to work through different methods based on feedback from the different parties involved, whether that's the contractor or the farmer, and develop the system that is going to work best for the needs of the farmer and to meet their needs in terms of yield, conservation, and sustainability. We design everything from random pattern tile systems to surface drainage systems to conventional interceptor to contour interceptor and contoured systems that can be used from controlled drainage to sub-irrigation. We are the world's leader in terms of drainage design, and we can work everywhere because drainage design is needed everywhere. If you want to contact us, please do so. Whether you just have questions, whether you want us to consider a field that you are looking at having a water management system designed for, that's great. Just give a call to either myself, Jeremy, or to Bob. Thank you so much for watching this video, and we look forward to hearing from you.